Welcome pre-cal students to the homework help video. Let's go ahead and get started. Here's the assignment in front of you, and I hope that this video will help you understand your questions that you have on the homework. For all of these problems, the directions state for you to write all of these logarithmic expressions with one logarithm. Okay, so let's go ahead and get started. Here we go. The first thing you always want to do is make sure there's no number or variable out front here to the left, and there's not in both of those. Let me fix my pen here real quick. Okay, the next thing we notice is that we have a plus sign here, and so what that means is and notice this, they both have the same base, which is very important. They both must have the same base, so you can write one logarithm, and because the two logs are being added, you can take the two arguments and multiply them. So the answer would be log base A of 150. Okay? Moving on to number 36. Now, remember there is a base 10 here and a base 10, so they both have the same bases. Also, there's nothing out to the left here and nothing here to the left, so we can write one logarithm. And by the way, you can put the 10 if you want to, and you don't have to. It's totally up to you. Okay? And we're going to multiply this argument here times this argument here. And so you would get 10 if you multiply 0.01 times 1,000. Moving on to number 37. Okay, now notice there's nothing to the left, nothing to the left. They both have the same base, so we're going to write the logarithm one time, and then notice the two logarithms are being subtracted, and so you divide the argument. So you would have 10,000 over 100, and of course I would want you to reduce that. And so when you reduce it, your zeros here would cancel, and you're left with 100 over 1, or just 100. Now, I can tell you right now they want you to take that further, okay? And I'm going to show you why. You kind of learn to recognize these after a while. And this one too, I should have taken number 36 further too, and I apologize. Log base A of 150, really nothing you can do. But this one here, remember there's a base 10 here, and anytime you have a base 10 and the argument is also can be written with a base 10, you really should take that a little further, and I apologize for not mentioning that. And so going back to number 36, what you should do is set it equal to x, and then bring this base over. You would have 10 equals 10 to the x, and then obviously there's a 1 right here, and so 1 equals x, so this entire expression right here ends up equaling 1. Take a look at 37. As soon as you realize you have a base 10 and you realize 100 can also be written with a base 10, and what I mean by that is 10 squared is 100. As soon as you realize that, you want to go ahead and take it further, and so set it equal to x, and then write 100 equals 10 to the x, and then of course 100 is the same thing as 10 squared equals 10 to the x, and then obviously x equals 2. So this entire expression right here ends up just equaling 2. So we are condensing these down to one logarithm, but anytime they can be taken further, you do need to do that. Okay, moving on to number 38. Okay, let's take a look at number 38. There's nothing to the left here, and there's nothing to the left here. Both of them are base E, so we write our logarithm one time. Notice the two logs are being subtracted, so we're going to write 54 divided by 6, and so your final answer is logarithm natural log of 9. Natural log of 9. Okay, moving on to number 39. Now do notice there is a 1/2 here, so we're going to have to rewrite the first logarithm with our 1/2 right here, and then notice I have a 3 right here, and so I'm going to have to move the 3 to an exponent. And now we're ready. Notice both of them have nothing left here to the left, okay? And then notice they're both a common log. They both have a base 10, and so your answer, and notice they're both being added, so your answer would be the logarithm of n to the 1/2 m to the third. And there we go. All right. Whenever two logarithms are being added, you multiply their arguments. Number 40, I'm going to have to take this 1/2 and move it right here. So I would have log a to the 1/2 power minus log of 2. Now notice they're both base 10, they're both a common log, and the two logarithms are being subtracted. So I'm going to write the logarithm of a to the 1/2 divided by 2. Whenever two logarithms are being subtracted, you divide their arguments. All right. Number 41. Okay, we're getting to a little more complex ones, but if you'll just be really careful and use parentheses when you need to, and so on and so forth, you should be fine. Now this 1/2 will have to be moved, this 4 will have to be moved, and so will the 3. Don't move a -3, just move the 3 and leave the negative sign there. Now let me go ahead and just do this in a little sloppy way to save time. So the 1/2 is gone, and I'm going to put it right here with the x. The 4 is now gone, and I'm going to put it right here with the y, and then this 3 is now gone, and I'm going to put it right here with the x. Okay, now notice they all have the same base. That's very important you check that. And then notice the first two logarithms are being added together, and so let's just do this one logarithm at a time. Okay, so I'm going to take my first two logarithms. They're being added, so I'm going to multiply my arguments. So x to the 1/2 times y to the 4th, okay? And then minus log base a of x cubed. Now hopefully you see what I've done. I've taken these first two logarithms here, and I've combined them. They're adding each other, they're adding to each other, and so I've written their arguments as a product. I've multiplied their arguments. Now the two leftover logarithms are subtracting, and so I'm going to write these two logarithms as one, and I'm going to divide the argument. So I would have x to the 1/2 y to the 4th over x to the 3rd power. Now this is of course pre-calculus class, so I would expect you students to know how to simplify this. Okay, x to the 1/2, x to the 3rd. What you should have learned in Algebra 2 is when you have one term up top, and we do, and one term in the denominator, and we do, and you have like bases, you write the base once in the numerator and you subtract the exponents. Okay, so my final answer would look like this. Well, almost my final answer. You have two x's here, so you write the x up top, you take 1/2 minus 3, and that would be -2.5, or in other words -5/2, y to the 4th, okay, all over 1. Hopefully you see what I did there. I took my x's, they're like bases, so I subtracted the exponents. 1/2 minus 3 is -2.5, or -5/2. Now you really don't want your final answer to have a negative exponent, so what you would do next is you would move the x to the -5/2 down to the denominator so that the 5/2 becomes positive. Okay, and now and not sure what happened there. There we go. And now we will have a positive 5/2 like this. Now I know a lot of you probably skipped steps here, and you probably just said, I'm going to take 3 minus 1/2 and put it in the bottom, and that's fine. That's totally fine. Either way is acceptable. Okay, but here is your final answer. Okay, right here. All right, let's move on. Okay, number 42. Let's take this 2/2, let's cross it off, and let's move it right here as a power. And let's take this 1/3, cross it off, and move it right here as a power. Okay, notice I have like bases, so I'm going to write log base a one time. Notice my two logarithms are being subtracted, so my argument would be x to the 2/5 power divided by y to the 1/3 power. Okay, and that is your total argument. I personally would put parentheses around it, and there's your answer. You cannot simplify that any further. Number 43. Okay, here we go. First of all, I'd be very careful here. I'd really take my time with this, okay? Do you see the square root of x? I would rewrite. I'm going to leave this alone right here. I'm just going to work with this for a second. If I have negative 2 natural log of the square root of x, I'm going to make that this first of all, okay? We should know that by now. There's really a 2 here and a 1 here, and so the square root of x is x to the 1/2 power. Next, see this 2 right here? I would bring this 2 out here so it's a power, and here's how that would work, okay? Your negative sign stays here. You have x to the 1/2 power, and then you bring this 2 out here so you have a 2 right here, okay? So whenever you have a power raised to a power, you multiply your exponents. So next I would have the natural log of just x to the 1 power, because 2 times 1/2 is 1. So please look at these steps and make sure you understand everything I did from here to here, here to here, and here to here, okay? The square root of x is x to the 1/2. Then you have x to the 1/2 to the 2nd power because you move this 2 out front. Then multiply those two together and that will leave you with x to the 1. Now let's bring down the first logarithm we have, and we would have this right here, okay? Now, notice I have like bases. They're both natural logs. Notice they're both being subtracted. So I'm going to write my logarithm one time, and then I'm going to divide my arguments. So x squared over x. And of course, it's x to the 1 power. Well, x squared over x reduces to just x. So I end up with the natural log of x. Okay? That's it. Hope that made sense. Let's move on to number 44. All right, now notice I have a 3 right here that's being multiplied times both of these logarithms, okay? So I'm going to take this 3 and multiply it through. So this parentheses is gone right here. I really have a 3 right here beside this natural log, and I also have a 3 right here. I hope that made sense. I just simply multiplied the 3 through the parentheses. But now that I've done that, hopefully you see that I will want to take this 3 and move it right here as an exponent, and take this 3 right here and move it as an exponent. So now I'm ready to go ahead and combine my logarithms. Notice they're all natural logs. So my first two logarithms are being added. I'm going to put the natural log of, well, 2x times x to the 3rd power. That would be 2x to the 4th. And then bring down your other logarithm. And now notice these two logarithms are being subtracted. So I'm going to write my logarithm once, and then put 2x to the 4th over y to the 3rd. And there we go. That's it, okay? Hope that made sense. Look all these steps over. Make sure you understood what I did when I multiplied the 3 through. And then because each natural log had a 3 out front, I wrote each of those 3's as an exponent, and then I combined all of my logarithms, okay? Let's move on to number 45. Okay, this problem here looks a little difficult, but it's really not that bad. Notice I have nothing to the left here, and I have nothing to the left here. They're both natural logs, so I'm going to write my natural log once. Notice the two logarithms are being subtracted, so I'm going to put up top x squared minus 4 over x plus 2. No, I have not. All right, now I can simplify that fraction. See this x squared minus 4? Really by now you should recognize that right away as being a perfect square and a perfect square. The square root of x squared would be an x, and the square root of 4 would be 2 and 2. Make one positive, make one negative. So this numerator right here now becomes this right here. And the reason that's important is now you can simplify, okay? X plus 2 cancels with x plus 2, so your final answer is the natural log of x minus 2. Be sure and put parentheses around that. That's 2 terms. Okay? That's very, very important. Moving on to number 46. Number 46. Alright, number 46. Notice I have nothing here to the left and nothing here to the left. Notice they're both a common log, and notice they're both being subtracted. So here we go. I write one logarithm, and then I would take x cubed minus 8 over x minus 2. Now, to be honest with you, students, you really should also recognize, I know this is more of a difficult factoring, but it's not that hard. You should realize you have a perfect cubed right here and a perfect cube right here. And so we can factor this pretty quickly. You've learned how to do that. You put a small parentheses and then a big parentheses. The cube root of x cubed is x. The cube root of 8 is 2. Whatever your sign is right here, in this case it's negative, you put that sign here. Then you look at this term and you multiply it by itself. So x times x is x squared. Then you take this term here and this term here, don't worry about the sign, and you multiply them together. X times 2 is 2x. Then you take this term here and you multiply it by itself. 2 times 2 is 4. And whenever this is negative here, everything here will be positive. So there we go. You just broke this down here into these two parentheses here. And then notice your x minus 2's cancel. So your final answer, and you have to put parentheses around this, because if you don't, well, I'll show you in just a second what it looks like. If you don't put parentheses around this, it looks like you're taking the logarithm of x squared, and then after you do that, you're adding 2x plus 4, and that's not correct, okay? You're taking the logarithm of this entire expression, okay? All right, let's move on to number 47. Okay, here we go. Notice there's nothing here to the left of this logarithm and nothing to the left. Notice they're both common logs, so they do have the same base. So I'm going to write the logarithm of x squared minus 5x minus 14. And notice there's a negative sign here. You're subtracting the two logarithms. So that would all be over x squared minus 4. Now you know what we're going to do. You can probably see it right away. We can factor the numerator and we can factor the denominator. So the numerator is the denominator is quite simple. It's the difference of two squares. So the square root of x squared is x. The square root of 4 is 2. And you would make one positive and make one negative. Up here we have a quadratic trinomial with a lead coefficient of 1. Those are the easy kinds. What two numbers multiply together give me negative 14, when add together give me a negative 5. And of course that's going to be a negative 7 and a positive 2. There we go. Okay, so now this is gone. And now let's do some canceling. Your x plus 2 would cancel with your x plus 2. And so your final answer would be the logarithm of x minus 7 over x minus 2. There we go. Okay, moving on to number 48. Okay, looks like we have quite a bit of a mess here, so let's really take our time and look this over. Notice first of all I have nothing to the left here and nothing to the left here, which is good. Notice I have base A and base A, which is good, and notice they're both being subtracted, which is good. Now I really don't like this square root of x in the denominator, so I'm going to go ahead and make this x to the what power? Do you remember? The 1/2 power. And then I'm going to bring that up top, and I'm going to make that x to the negative 1/2. All right? Now, when I come over here, I notice I have the square root of a to the x. Now, let me do some work over here off to the side for you, okay? The square root of ax is the same thing as ax to the 1/2 power. And you really have a power here of 1 and a power here of 1. Take the 1/2 and multiply it through, and you would have a to the 1/2, x to the 1/2. Okay? Now, that can replace this right here. So let's go over that again. I have the square root of a to the x, which is the same thing as ax to the 1/2 power. Then take your 1/2 and multiply it through, and you're left with a to the 1/2, x to the 1/2. So now what I have is simply this. I have logarithm of base A of ax to the negative 1/2 power minus the logarithm of the logarithm base A of a to the 1/2 x to the 1/2. There we go. Now, notice the two logarithms are subtracting, and so what you would have next would be log base a of a x to the negative 1/2 over a to the 1/2 x to the 1/2. Now please watch your signs very carefully. This is not that difficult. I mean, you have graphing calculators you can use, so fractions should not be a problem. And if you just take your time and use the properties that you know, you should be fine. Let me go ahead and slide this over just a little, get a little more room. Actually, I'm going to leave that there because I want to show you something about their answer. I wouldn't say I disagree, I just think they're being a little inconsistent. But anyways, okay, notice I have a to the 1 power. Well, what I've taught you to do is when you have one term up top and one term in the bottom, which you do, and you have like bases, a and a, you write the base once in the numerator and you subtract. So 1 minus 1/2 is a to the 1/2. Then, same thing with your x's, okay? We're going to put the x right here. And what we would have is negative 1/2 minus 1/2, okay? Which is going to give you a negative 1, okay? Negative 1. Negative 1/2 minus 1/2, negative 1. Now, of course, I don't want x to the negative 1, so I'm going to take my x to the negative 1, and I'm going to bring it down to the denominator. And when I do that, my exponent will then become positive. Okay, so x to the 1 power. And of course, x to the 1 power is really just x, okay? So there we go. Now let me do something really quick I need to do here. There we go. All right, now, so what we did is we took this whole expression right here, and we simplified. If you need to see it again, pause the video, back it up, and watch again, okay? So now this whole expression is gone, and what I'm left with is the logarithm of a of this expression here. Now on a test or a quiz, this is your final answer in my opinion. Now in case you're concerned that I'm teaching you something that's wrong because this answer here does not match this answer here, I'm going to quickly show you what they did. But for me, this answer here is what I want. I'm going to tell you why, okay? They tell you in the directions to simplify this or combine it down to one logarithm. So you do that, and then they want you to split it back up again, which is kind of confusing for students, okay? It's either combine them or don't. But what they did for their final answer is they noticed they had a base a here, and they noticed they had a base a here, and they noticed that the argument was being divided, so they went backwards and they wrote log base a of a to the 1/2 minus log base a of x. Now why they subtracted the two logs is, remember, when your arguments are dividing, that's the same thing as subtracting your two logarithms. And now they noticed here they had a like base. So if you'll let me show you really quick here, this logarithm right here, log base a of a to the 1/2, we're going to say it equals x. And then we're going to solve for x. We're going to write it exponentially. A to the 1/2 equals a to the x, and look what x has to equal, 1/2. So this whole expression here became 1/2. And that's how they got their final answer. 1/2 minus log base a of x. And of course, to me, it's kind of inconsistent to ask you to combine the logs and then pull them apart. And so I am totally fine with this expression right here, okay? All right, moving on to number 49. All right, this looks like a little bit of work. Let's see if we can figure this out, okay? First of all, you have a 3 outside of a bracket right here, and you're going to have to take that 3 and multiply it through. So when you multiply that 3 through, you're going to have a 3 right here. I'll change color so you can see. You're going to have a 3 in front of this logarithm, and you're going to have a 3 in front of this logarithm, okay? Well, next, after that, you're going to cross this 3 off, of course, and write it right here as a power. And you're going to cross this 3 off right here and write it right here as a power. Now, let's continue on, okay? Let's kind of see what happens here. And I don't have the answer in front of me. I'm not going to go get my book and look that up, but I'm not sure how far they want us to take this. I'm not going to make you take it that far. Okay, first of all, notice that I should show you one thing first. Let's go back to the original problem here, okay? I do notice a slight problem we could have. we better first go ahead and simplify inside the brackets. That would be the smart thing to do. So let me go ahead and back up and say that, okay? I would first of all put your -3 like that. And the reason I'm concerned is the other problems that we did, and I should have explained this better, the other problem that we did somewhere where there was a 3 right here. Notice in number 44, when there was a 3 outside the parentheses here, I noticed there was a plus sign, so I really didn't see any problems. I knew you would just multiply, the first two would be added together, but I'm seeing in this problem that I have a negative sign right here. So the safe thing to do really in all of these is go ahead and combine inside the bracket first, okay? And so notice you have a natural log and a natural log being added. So I'm going to write natural log of x minus 5 times x plus 5, all right? So there we go. What I did is this. I notice, if you'll just ignore everything in the problem except that part right there, notice you have a natural log and a natural log being added, and so you multiply their arguments together, and that's what I did. Okay? So now, having done that, I can now take this 3 and multiply it through. So if I take this 3 and multiply it through, it does not get multiplied by the parentheses, it gets multiplied by the logarithm. So now I have 3 times the natural log of x minus 5, x plus 5, okay? Now, if I want to move this 3, which I do, this 3 right here should be moved as a power. Do understand it will be a power for the entire argument, okay? So this whole thing is to the third power. And now I have a subtraction sign here, so I'm going to write the natural log of x over x minus 5, x plus 5, all of that to the third power. And that is your correct answer. I don't see them wanting you to take that any further. In my opinion, that would be a ton of work, and so this should be sufficient. Okay? All right, moving on to number 50. Well, let's go ahead and start inside of our brackets first. Notice I have a natural log here. I'm going to circle it for you. And a natural log here, and they're both being subtracted. Okay, so I'm going to bring down my 2/3, I'm going to bring down my bracket, and I'm going to write 1 natural log, and I'm going to write x squared minus 9 over x plus 3. I hope that makes sense. Okay, I took this log here and this logarithm here. I noticed they're being subtracted, so I combined them into one log. Now you should see what we're going to do right away, okay? X squared minus 9 is x plus 3 when you factor it, x minus 3, and so x plus 3 cancels with x plus 3, and so really what you have now is 2/3 and then your bracket and then natural log of x minus 3. I hope that makes sense, okay? And then we're going to bring down, we already combined these two here, so we're going to bring down our last logarithm, which would be plus natural log of x plus y, okay? Now, yes, you do have a 2/3, and yes, you would multiply it times this logarithm. But when you do that, remember the 2/3 does not get multiplied by the x minus 3. The 2/3 just gets multiplied by the natural log, and so I have a 2/3 out front. Well, you should know by now, if we have a 2/3 out front, that really has to be written as a power. So now I have x minus 3 to the 2/3 power. Now notice these two are being multiplied, okay, or being added, excuse me. So I'm going to write 1 logarithm, put a bracket, and then I'm going to write x minus 3 to the 2/3 power times x plus y. And again, I really cannot imagine them wanting you to take that any further at all. Okay, that should totally be sufficient. All right, number 50. Moving on to number 51. Okay, here we go. Well, this is going to be interesting. I'm first of all going to take this 3/2 and I'm going to move it. I'm going to put parentheses and put all of that to the 2/3 power, and then I'm going to take this 4/5 and I'm going to move it and take all of this to the 4/5 power. So we have a little bit of work to do, students, okay? We really do. First of all, let's talk about 4 and x to the 6th to the 2/3 power. Let's take this expression and let's work on it for a little bit. I'm going to erase it when I'm done, so be careful, okay? I have 4x to the 6th, all of that to the 2/3 power. Now when you multiply that through, there's a 1 right there. You would now have 4 to the 2/3 power x to the 4th power, because 6 times 2/3 is 4. Now, what is 4 to the 2/3 power? Well, that's the cubed root of 4 to the 2nd power. All right. Now, you can't simplify that. You cannot take 4 times 4 is 16 and take the cube root of 16. There is no cube root of 16. Okay, so we can't take that any further. So we have taken this whole expression right here and we've simplified it down to this. Okay, so I'm going to go ahead and erase that like I said I was going to, and now I'm going to write this. I'm going to write the natural log of 4 to the 2/3 power x to the 4th power. Now put your minus sign, and now I'm going to put my natural log here, and now let's work with this expression right here. 2y to the 10th to the 4/5 power. So 2y to the 10th, all of that to the 4/5 power. Now, there is a 1 here, so 4/5 times 1 gives me 2 to the 4/5 power, okay? And then y, 10 times 4/5 would be 8, all right? Y to the 8th power, 10 times 4/5. This is going to be a really difficult problem, so I need you to really stay with me and really pay attention, okay? This is not going to be easy. Okay, there. So I took this, simplified it down to this. I took this and simplified it down to this. Now let me erase this over here, and this is not going to be easy. You'll probably have to pause the video a lot, so please pay close attention. We're actually going to do, we're going to deal with a lot of algebra in this problem, okay? Algebra 2. Okay, my two logarithms are being subtracted. I'm going to write the logarithm one time, and for my base I'm going to put 4, or for my numerator 4 to the 2/3, x to the 4th, all over 2, 4 to the 5ths, y to the 8th. Now normally you would look at that and say, okay, we're finished. We have no like bases anywhere that we can combine, but guys, you got to learn to think out of the box a little bit, okay? See this 4 to the 2/3 right here? I'm going to pull it away and I'm going to do something to it. You're not going to like this, but this is what you do in higher level math. As soon as you got to learn to recognize this. As soon as I see this 4 here and I see I have a 2 down here, I'm like, hold it. I can rewrite my 4 as 2 squared and put the 2/3 on the outside. So instead of putting a 4, I now put 2 squared. And by doing that, I now have a power to a power. So you multiply your powers together and you get 2 to the 4/3. So 4 to the 2/3, after I did all this simplifying, became 2 to the 4/3. So now I'm going to put that back over here. So take some really good notes. Why is that a big deal? Well, guys, now you have like bases right here. And whenever you have like bases, remember what to do? Whenever you have like bases, when you have one term over one term, and we do, and you have a like base over a like base, you write the like base once and you subtract the exponents. Now, I don't have my calculator with me. Sorry guys, excuse me. But 4/3 minus 4/5 would be what? 20/15 minus 12/15. So you would get 8/15. And so you have 2, when you take 4/3 minus 4/5, you get 8/15 power. And of course your x stays to the 4th power, and your y would be to the 8th power. Now I can't see that being simplified any further, okay? And I don't have my book with me. I usually do. I apologize. The only thing I could think of is maybe this 2 to the 8/15 power. Let's write it real quick as a radical. I don't think it's going to change anything. We have the 15th root of 2 to the 8th power. And that cannot be simplified. So as far as I can see, unless I'm missing something somewhere, this would be your final answer. Put parentheses around it. Pretty ugly parentheses, but there we go. Okay? All right, moving on to the last one, number 52, and we're finally done. So I'm sure they're going to end with a really good one here, okay? All right, well, the fifth root of x to the third would be the same thing as the natural log of x to the 3/5 plus the natural log of, well, the cube root of y squared would be the same thing as y to the 2/3 power minus the natural log of, let's be careful with this, okay? This would be 16 to the 1/4 power z to the 5th power. Now the only problem I have with this, actually I should have showed just before I even wrote that, so let me back up. Actually, you should see right away that we know the fourth root of 16. Now, let me stop and show you something. If you had the fourth root of 16 plus z to the 5th or minus z to the 5th, you could not take the fourth root of 16 because you would have two terms right here. Please don't forget that. But because I have one term right here, I am allowed to go ahead and take the fourth root of 16, and the fourth root of 16 is 2, and I'm left over with the fourth root of z to the 5th. Do you see what I did? I took the fourth root of 16, so I crossed it off, and the fourth root of 16 is 2, so I put a 2 on the outside. But now I've got to take this a little further. So what I have now, this right here, would then be 2z, and the z would be to the 5/4 power. Do you see that? The fourth root of z to the 5th is z to the 5/4 power. A lot of simplifying, a lot of algebra in these. So this will go right here, and then I'll go ahead and put my parentheses back, okay? So there we go. Now, my advice to you is, yes, I can see that we have 120 out here, but I would hold off on that until the very end. So I'm going to forget this 120 until the very end. I'm going to go ahead and take my first two logarithms. They're being added right here. So I'm going to combine these two logarithms right here, and I'm going to put the natural log of x to the 3/5, y to the 2/3, and then minus the natural log of 2z to the 5/4. Okay? Now, the two logarithms are being subtracted, so I'm going to take these two logarithms and put them together. I will have the natural log of x to the 3/5, y to the 2/3, all over 2z to the 5/4. Okay, let me get a drink here real quick. And there we go. Okay, now what I'm going to do, I've taken all of this right here, all of this. I took the first two, simplified them down to this, then I took these two and simplified them down to this right here. So what I'm going to do now is take my eraser, I'm going to erase all of this. I'm going to bring this back up, and now what I have is all of this is still in parentheses with a 120 on the outside. So you know what we're going to do? We're going to multiply 120 times this logarithm. Now when I do that, I'm going to have the 120 right next to the logarithm. You do not multiply the 120 times the argument, it goes right here. And then of course you should know by now that when you have 120 out front, that really becomes a power for your entire argument. So I move it right here. So now, because I have one term here and one term here, I must take this 120 and multiply it by each exponent. So your final answer is going to be this, okay? 3/5 times 120. I'm going to try to do this in my head. I don't have my calculator with me. Let's see, would give me 224. 24 times 3 would be 72. So x, I did that in my head, I could be wrong, but with a calculator, take 3/5 times 120, I'm getting 72. Then take 2/3 times 120, and I believe you'll get 80. So y to the 80 all over. Now don't forget the 2. The 2 has a power of 1, and 120 times 1 is 120. And if you're wondering, I'm kind of laughing, but no, you do not need to simplify 2 to 120. And then 120 times 5/4 would give you, I believe, 150. But you can type that in on your own and see what you would get, okay? 5/4 times 120, I think, is 150. Well, that's a really long problem, but it's been a good problem. That's a lot of good Algebra 2 review for you guys, and there's your answer right there. Okay, and that's it for the homework help video. I hope this has been a help to you. If you have any questions, don't hesitate to call or email.